All right, Paul, so let's have a review of where we're at. The chance of there being intelligent life out there, alien intelligent life, is going to depend on the number of stars that there are in the universe.
Which we kind of know.
Right, times the fraction of planets.
Which we kind of know.
Times the number of those planets which are habitable.
Which we can at least guess.
Times the likelihood of life developing on one of those planets.
Which we have no idea about.
Times the likelihood of that life becoming intelligent.
Which we also have no idea about.
And then finally we have our last term.
And this is in many ways the trickiest of them all. It's the time term. How long, let's say on some planet, we have actually got to this pinnacle of evolution, we've got intelligent life forms capable of doing astrophysics and wondering about how much life there is in space. How long do they hang around on a planet? If they only hang around a short time, they reach the pinnacle of intelligence and then decide to give up reproducing or something like that, and some excess of philosophical purity, then every planet will reach intelligent life form and then go away. In that case, when we go out into space, we'll find lots of planets that once had intelligent life forms, but they've gone. There'll be very few around today. So unless we know how long the life hangs around, we don't know, intelligent life hangs around, we don't know how many life forms are going to be out there right now.
Let's start with how long we've been around. So we're going to start and do an analogy here, where we're going to take the entire history of the universe and cram it into a year.
Because people don't tend to realise, people are very comfortable with how big space is, people are not comfortable with how long time is. I think this is part of the reason people find evolution difficult to grasp, because people don't have a real gut feeling of what 13, 14 billion years actually means. This analogy may help with that.
So let's start with the Big Bang, as you would expect it to be, on the 1st of January.
At the scale, the Earth will form early September.
And that means that multicellular life forms in mid-December. That's stuff beyond bacteria.
Humans evolved language about 4 minutes before midnight.
And Stonehenge was then built 11 seconds before midnight.
And radio was invented by Marconi about 0.2 seconds before midnight.
So all of the actions really crammed into the last day of the universe as far as intelligent life is concerned.
So we really haven't been intelligent very long on the scheme of things. This, by the way, is why we should always be very polite to any aliens we meet. I mean, if you just imagine it's taken us this long to get here, and we would only be at the level where we can have a decent war with ourselves for the last 0.2 seconds of a year. Odds are if we run into aliens, they either went 10% faster or 10% slower, or they had a star that formed a bit earlier or later. If they went through this 10% slower, they're back at about the level of slime molds, in which case interstellar war will consist of us going...
Or them doing the same to us.
If they got to intelligence.
So you don't think it's going to be Princess Leia and going out against the evil Emperor?
I think if we meet any aliens, they're either going to be much more advanced than us, in which case we should be really, really nice to them, or we're much less advanced, in which case it doesn't really matter what we do to them.
Well, we should be nice.
We should be nice, yes. Even bacteria have feelings, maybe. So, as we've only been intelligent for a very short time, the real question for how long a race stays intelligent, we know it's at least how long humans have had language, which is about 80,000 years maybe. But it could be much more than that. How long are we going to hang around as intelligence?
So, Paul, I think what you've done here is you've plotted 3 possibilities for a distribution of something.
This is a really weird argument. It's a fun argument, and I'll try and explain it to you. You have to take it with a pinch of salt. But let's try out this argument on you. This is an argument that suggests that, in fact, humans are not going to last very long. So let's do an analogy. Let's imagine that Brian, who was brought up in Alaska, was actually brought up in a cave in Alaska, and he'd never met any other humans until reaching adulthood. Now, sitting there in his cave thinking deep thoughts, he came up with 3 possible hypotheses for what the human race is like. This is the height of humans. And hypothesis number 1 says the distribution of heights is something like this green line over here, which says that the most typical height is about 1 metre, 100 centimetres, and a few really tall people might get up to 160 or 170 centimetres, and small people might be down to the size of 70 or 80 centimetres. So that's the small person hypothesis. And then there's the tall person hypothesis, that the average height's like 2.5 metres, and a few really short people might be down around 180 centimetres. Or there's the middle hypothesis, that in fact the average height is maybe about 170 centimetres. Now, Brian doesn't know, he's never met any other human, he's only got one data point, Brian.
So I'm 177 centimeters tall, and so I look at these three things, and I know I must be a little taller than the average person because we all want to be. And so this one seems to make sense to me. I'm a little taller than average. I'm not a giant. I'm not a midget.
Because if this model was true, Brian would be one of the absolute tallest people in the world. If this model was true, Brian would be one of the smallest. It's far more probable that, in fact, Brian is fairly average. It's probable that most of us are pretty average in most ways. So you'd think, just one data point you can't say very much, but one data point might be enough for such different hypotheses, and you'd expect on one data point that we would be typical.
So why don't you compare me against the average American?
So here's the actual data, and in fact you're pretty close to the average American.
Yeah, I'm pretty... Well, I was born an American, so it makes sense. So I was right. So
Okay.
I have a good idea.
Now let's try and apply the same argument to how long the human race is going to be around. This is where it gets a bit hairy. So here is the graph of the population of humanity versus time. And you can see not many people in 1000 BC, not many people around 0, not many people in 1000, and then suddenly, whoop, population of the world's gone through the roof in the last 50 to 100 years. That's what we know in the past. That's real data. What's going to happen in the future? Well, let's come up with two hypotheses. So one hypothesis is the pessimistic hypothesis, is that the population of the world will go something like this.
So we are here now. We're going to maybe get a little bit bigger, but life's going to be bad somehow in the future. There are not going to be very many humans in the future.
Okay, so something goes wrong, whether it be global warming or a nuclear war, or everyone gets so addicted to computer games they forget to have children. Something goes horribly wrong and the population of the world will crash. In this case, this T is going to be very short. Intelligent life is a very short-lived pattern. Something goes wrong. Whenever you get intelligence, it doesn't last very long. Or let's have the optimistic hypothesis. I guess unless you hate humans, okay, this is a pessimistic hypothesis. So, for example, it could be that population keeps going up and then plateaus at about the carrying capacity of the world. I mean, probably can't get more than 20 billion people on the Earth for any length of time, no matter how good our technology is. But then maybe around here, say about 4000 AD, we go and colonize the rest of the solar system. And then maybe around 6000 AD, we go off and colonize the rest of the galaxy with interstellar arc ships or something like that. So these are our two hypotheses. One in which, in this case, T is very long. We're going to remain intelligent
Forever.
forever, at least
Yes.
until the big crunch.
I like this one.
Or we could be in the pessimistic point of view, where intelligence is a blip, and we go back to the cockroaches and the kangaroos after a short period of time.
All right, so if we use the argument we used for my height, I want to be an average person. And if I look here, if I look at when I lived, I'm right here is my lifetime. So I'm right, very normal. I'm average within the distribution. And if I go to this one, the second one, then I'm here, and I'm one of the first people. I'm way on the side. So I'm not very average here.
In this model, the vast majority of all the humans that are ever going to live will be living on a distant star, a million years in the future. We are the extreme tail of the distribution.
So what we're saying is that if you use this argument,
That we
that
are
would
likely to be
indicate,
typical.
yeah, that we're typical, then we're heading for a fall. That is, the lifespan of intelligent life, at least on planet Earth, if we're typical, will indeed be short. That time period is a small number, not a large one.
So, Brian, do you believe that
I
argument?
don't want to believe it, but it's kind of hard to know.
I think it's wrong for the following reason, and feel free to disagree with me on this. We're assuming that we are randomly chosen from the distribution of all people, that we could be anybody.
Yes.
But in fact, the fact that we're asking this question means that we don't know whether humanity is going to go on for a long time and colonize the galaxy or just stay on the Earth. So in fact, the true graph shouldn't be the number of all people that ever are, but the number of all people who ever are who don't know whether humanity is going to spread around the universe. Because if you know, then you wouldn't be asking this question. So the true population we should be drawn from is all people who ever lived who could have asked this question.
So do you think we should cut it off here or something then?
Yes, because by the time we spread over lots of planets, we know humanity is going to last a long time. So I think all this bit of here must be cut away. It's only in this very first stage, regardless of what happens in the future, that we could even ask this question. I think that's my argument. Many people would disagree with that.
It's a tricky argument and probably means that we really don't know the answer in the end.
Indeed. So what do we get? A full Drake equation. And we know this term, know that term, some idea of this one. It's these three that are the killers. What are the odds of forming life? What are the odds of life forming intelligence? what are the odds of it hanging around for any decent length of time? And really we get any answer we like. We could come up with perfectly plausible values for all of these things that mean we are alone in the universe despite this huge number of stars, or the universe is teeming with life. We really don't know.